My name is Sean Anderson. I teach avionics, aircraft electrical systems for A&Ps, and even a few classes for pilots at Southern Utah University. I'm doing this recording, this explanation of one of the diagrams that students will see when they take their test to become an airframe and power plant mechanic. The FAA loves their landing gear circuits, and actually, I do too, as far as being able to explain how circuits work, avionics, and subjects like that. They don't have too much of an explanation of this one, and so I thought I could do better than what I've found on YouTube or elsewhere. And mainly, I am going to emphasize in how the circuit works. There are some prepware questions that students will want to get into more deeply, that basically if one of these wires with the numbers that they specify on here, if they are open, then will the circuit work, or which ones will cause it not to work? But I'll mainly emphasize for the most part just how it works with some stuff that I've found to kind of show it through PowerPoint slides of the flow of electricity. So first of all, this is the generals figure 15, but it is also airframe figure 19, which isn't as good of a quality of image. That's why I'm using the one from generals. So the first thing I would say with this diagram is that there's a few things that are missing that I would want the FAA to put on here to make the drawing better, or at least easier to understand what is going on. For example, these up limit switches, down limit switches, and such do not show on this diagram what position they are in or what the alternate position is. So that's my next little slide on here to basically show that information. So we've got the up limit switch, which on the picture, if it's up in this direction, then we're basically saying that the landing gear is up. And if it's shown in the position right now, that this one is in this shown position, it is the landing gear are down, as in down and locked. Our gear safety switch, another important one, is that it is in the air mode, as if it's up, and if it's in the position shown, it's kind of down on the drawing here. This is in the weight on wheels for safety's sake, or squats, which is another name for this. Other one here is the idle for the throttle. Basically, there's two switches implying maybe two engines for the aircraft. If either one of these is in the idle position, it closes the circuit to allow power to flow. Last of all, down is basically what is shown for this position right now. If the nose gear is not down, then it's in the alternate position, which will be some of the circuits. So there's several different scenarios here, going through them one at a time. Let's go to the next one here and have power flow around and follow it along here. It's basically going through these switches and it energizes this relay. And so once it energizes this relay, it pulls it down and allows power to flow across there to the motor to operate it and basically make the landing gear go up. So the first thing is we go back to what it was doing, was that it was the up position for this gear switch. If we select it up, then it allows power to go through this pathway coming around as shown before. And so it basically goes through the squat switch, which we're saying it is in the air mode, and allowed it to go here and energize the relay. If this was not in the air mode and it was on the ground, power would go through this path here, wire number 11, and basically go to the horn, and we'd get a horn going off saying that you moved your selector switch to the up position, but you're on the ground. At least the electrical circuit believes that. So it's warning the pilot to be careful, because if they try to take off and they have the gear in that position, it could be very dangerous. The gear starts to retract as soon as there's just enough weight off the gear, and then it might not have enough airspeed that it comes back to the ground, but the gear have already started to retract. So that would be a dangerous scenario on here. If we do the very simple circuit here, it's not using a relay as they do in the Airframe textbook, but they just have it go through this down limit switch to go directly to the motor that's going to operate it in a different direction that will cause the gear to be moved to the down position. There are definitely some aircraft where it's electrically operated and it moves all three gear at once based on one motor. So in that sense, it does make sense to have it drawn this way. However, I'm not sure why the FAA chose, except for just simplicity, to put a relay on one side of going up, but not for going down. Maybe because it goes more power, but that would imply whatever power we need for the motor is going to be going through all of these other switches. Okay, next one will be a little bit easier. Oh, and I should finish. Once the gear have extended fully, the switch now moves to the down position and it removes power from here. So once the gear have moved into the position that we have requested, or basically said that we want by moving it up or down, the switches, as they get into that proper position, moved where in this case it's the down, and now power can't get past here, and so the motor ceases to operate. So this bottom circuit, we're just going through the green light and basically getting this green light to come on, basically with power going through this down switch for the nose gear. And then there is a left gear and a right gear down switches. And so if all three landing gear are down, then it allows power to continue through the light to the ground source. And basically the light comes on. So basically, if one of these switches is in the wrong position, no light comes on. So we don't have an individual light for each landing gear on the indication for this one. Let's move to the next one. And we'll go if the nose gear is in the up position. And so I don't know if I like that music yet, but basically we have power flowing through the idle switch. Doesn't matter which one, but if both of them are pulled back to idle, it allows the current to flow through to this little nav bypass relay and through the down limit switch. And this is implying that it's in that not down position, flows through here, and is just an alternate source to go to the horn to make it go off. So this just lets the pilot know that, hey, your gear is not down, but your engine power has moved to the idle position, which makes me think you're getting ready to land. And it's going to give a warning saying, hey, you need to extend your gear because we do not want to land with the gear up. Now, this relay here that they call now switch bypass relay would be what I would consider to be a time delay, so that maybe for a minute, 5 minutes, that you push it and the horn goes off. But if we haven't corrected it and done something different of moving the, more power or something else, then it'll make the horn go off again. This next one is basically showing the circuit for a testing phase. So we have green, or sorry, it's going to the red and green light bulbs, but we actually have to move the lens in here, push it down, and that will bypass the circuit here to where it is able to test it. So all that is for is to test the circuit to make sure that the light bulbs have not burned out. Be better if they were LED, but even if they're LED, we want to test them and make sure that they're good. So we push the red, light comes on, we push the green, and the light comes on. So it's just a matter of pushing it, and then we release it, those lights will come off. Okay, I have another one here. And this is just showing power is available on wire 19 going to the up limit switch. And if we move it to where it is in and makes it so the gear is in the up position, or as far as not, this is in the not up position here, we're going to get some indication as we follow it down through the red light. So basically that's just completing the circuit through here, and that's what this wire 8 is for, is it's hooked up to this one. And so if our landing gear is in the up position, we basically have this red light coming on. Now myself, I would not use a red light to indicate that the gear is up, because red just makes me think that something's not right. Like we might have a transition. Some aircraft will show a light come on while the gear are in transit or transiting from up to down or down to up. So that transition process. Um, and then on some of the big aircraft I've worked on and seen, the indication for landing gear when they're in cruise flight, they don't need to know it. It just actually disappears. And then when they need to know, like they reduce airspeed and they get at lower altitudes, such as below 2,500 feet, then the indication comes back up to show which position it's in. So that pretty much covers it for our landing gear for generals and airframe, as they think it's very important. So it's good to understand how this works. Thank you.